Hello everyone, and today we will see some, and this is the seventh video of our series. And today we will see three questions. All three questions are very short, 10 marks questions, out of which two are theoretical and one is numerical. Numerical is very small, and but it is based on formula. So this is the first question. Discuss briefly functional differences between fan, a blower, and a compressor. This question is not only from civil service point of view, but it is also important from interview point of view. Okay, whenever you are going for interview of PSU or any private job or any civil service or any other organization. So here I will tell the orally difference and I will write some points. Okay, so you can make the full length answer by yourself. So fan, blower, and compressor. So the main difference is functionally it is due to pressure ratio. So in fan, pressure ratio it is limited to 1.11. In blower, it is in between 1.11 to 1.2, and if it is greater than 1.2, then it is called compressor. The main function of the fan, it is to move the stagnant air or any stagnant fluid is there, air or any gas. If we use fan, so it will only try to move here and there in a room or in a given volume. And if we want to move stagnation fluid to other one place to another place, then it there should be pressure difference. So this much pressure difference 1.11, it is caused to move your air from here to there, and generally it is used for as a in a human comfort as well as in some industrial purpose also, but it is only for partial drying and all that thing. So the main purpose of the fan is to move the stagnant air from one place to another place and to provide comfort condition. And uh, the majority of fan, the working fluid is air. Now we talk if we talk about blowers. So blower has some higher pressure ratio compared to that, but the velocity at exit of the blower is very high, is very high compared to fan. Okay, and at the exit of the blower, when you see the blower, the air is coming at very fast, higher rate. So this is the difference in the blower and fan. And the other thing, any fluid, whether it may be a gas or maybe a air, any gas or air can be used in the blower. And generally I have seen in industrial practices that lpg is also the liquefied petroleum gas is first sucked down from the storage, and it is converted into the gas and then burned out, and that burnt gases can also be blow down through the blower. Okay, to increase the velocity of burnt gases also, and that this facility we cannot achieve in fan as well as in compressor also. This facility we cannot achieve. And this is the main reason and the main function of the blower. In compressor, to increase the compressor, that means to compress the any fluid, any compressible fluid which is having, which you want pressure ratio greater than 1.2. So in compressor, we whenever we require higher pressure, so then and only we will use compressor. But in the compressor, the main function of the compressor is not to provide the any working fluid or air or any gas at a high velocity, but to provide at higher pressure. Velocity may or may not be higher at that point. So this is the main functional difference between the compressor, fans, and blowers. Next topic, this is from power plant, that describe the following terms with reference to the steam nozzle. What is the efficiency of the nozzle and velocity coefficient? So steam nozzle, we can say that like this. If we take the assumption of adiabatic, sorry, insulated, but there is a it is a highly frictional flow because steam is coming at very high speed, very low speed, sorry, but it when it strike to the walls of the nozzle and at the exit its velocity get increased, but there are frictional losses are very high. So we can say that at a adiabatic also, we can the flow in nozzle we can say that adiabatic, but we cannot say that isentropic, because if a flow want to be isentropic, then it must be reversible and adiabatic. And when the process is reversible, when there is a no loss associated with frictions. So generally, uh, efficiency is what? Actual condition divided by ideal operating conditions. Okay, in ideal operating condition, uh, so steam must be expand. If we draw HS diagram over here, HS diagram, so steam must expand isentropically 1 to 2, but in actual case it is expanding like this, 2s. So efficiency of the nozzle is what? Enthalpy difference H1 minus H2, sorry, here H2s, but and in actual condition it is H2, it is H2 actual condition, and in a ideal condition H1 minus H2s. Okay, so this is the efficiency of the nozzle. But nozzle, we are not measuring the enthalpy, but in nozzle actual case we are measuring the generally we are measuring the velocity. So nozzle efficiency we can write out in the velocity difference, delta velocity in actual, and delta velocity ideal. Okay, or we can say that kinetic energy change, not velocity change, sorry, it's my mistake, it's a kinetic energy change, delta kinetic energy actual and delta kinetic energy ideal. Okay, so what is the actual it is having half half mv square, but mass of the steam is remains constant. Okay, so v1 square minus v2 square divided by v1 square minus v2s square. But initial velocity, as I said, that it's our assumption, we have to write in the starting of the question that initial velocity is very low, so we can neglect this term, and minus minuses also get cancelled. So v2 square divided by v2s, that means s, that is at the isentropic condition. So efficiency of the nozzle is also can be written by v2 by vs whole square, v2 by v2s whole square, and v2 is exit velocity. Now the another is velocity coefficient. So velocity coefficient cv, it is directly, it is a ratio of actual velocity at exit to isentropic condition velocity at exit. And if you want to relate all this, so efficiency of the steam nozzle is equal to uh, velocity coefficient square. So this is the relation between them, and all this about the what is high efficiency and velocity coefficient. Now if we move about, I hope you understand this, why from where this v1 minus v2 came, because kinetic energy initial is 1 by 2 m v1 square, and final is 1 by 2 m v2 square, but mass is constant, half is constant, so it will get cancelled out from numerator and denominator. And initially velocities we have assumed very small, so v1 square will also get cancelled out and it is tends to 0. So now third question of today is uh, moist air, this is refrigeration air conditioning, and generally this question has been asked, and the similar kind of question has been asked in engineering service prelim examination also 2021, and gate exam also, gate 2020 as well as 2021 also, and in this year civil service exams also. So and this kind of questions are generally asked in every psu's exams also. Okay, so a moist air has a dry bulb temperature, it is given td. Specific humidity, I am writing specific humidity as a omega is equal to 11.5 gram of water per kg of dry air, but I am writing as in a standard unit, SI unit, 11.5 10 power minus 3 kg per kg of dry air. Okay, kg per kg of dry air, sorry, let me write neat in neat manner, kg per kg of dry air. If the saturation pressure of water vapor at 30 degrees Celsius is 4.24 kilopascal, so partial pressure of water vapor at saturation condition PVS is 4.24 kilopascal, and total pressure PT is 90 kilopascal. Okay. So what is the relative humidity? Phi. So this question is based on equation and memories. So if we know the equation of specific humidity, omega is equal to 0.622 PV, and here PV is what? Actual pressure, not saturation. Saturation pressure is what? When the air is totally saturated, it can contain maximum amount of vapor, so then it is called saturation vapor. But whenever it is not saturated, we will denote with PV. So this formula 0.622 PV divided by PT minus PV. So omega is what? It is given 11.5 into 10 power minus 3.622, and total pressure is given at PT 90 kilopascal. So whenever you put this, so you will get one equation, and when you solve this, you will get 1.633 kilopascal. It is the actual vapor pressure of vapor in the given condition. Now the relative humidity, it is given by partial pressure of water vapor in actual condition and partial pressure of water vapor in saturated condition multiplied by 100. So it is 1.633 divided by what is saturation condition 4.24. It is 4.24 multiplied by 100. So when you solve this, you will get as a 38.53%. So this is the answer of the relative humidity. So today we have solved three small questions, and tomorrow we will see one power plant question based on the Rankine cycle. So stay tuned with it, and thank you for watching this video. Hope you like this, and subscribe this channel and share with your friends also to get the maximum.